Okay, so now that you've finished the rewind, let's go ahead and go over a couple of these. Some of them are really simple, a couple of them are a little bit more complicated. So when we're looking at number one is an isosceles triangle, so I know automatically that if these two sides are congruent, then the opposite angles must also be congruent. So angle X and Z must also be congruent. If Y is equal to 90, which we know because it's a right angle, then I know that X and Z must both be 45 degrees because the sum of those angles would be 180. Number 4 is a right triangle as well, but in number 4 we're looking for a length, not an angle. So I know that these two angles are equal, which means they must be 45, but I'm looking for BC. So if I'm looking for a missing side of a right triangle, I can use the Pythagorean theorem to figure that out. So the Pythagorean theorem here would look like this: a squared plus b squared equals c squared, where c is always the longest side, the hypotenuse. So a squared is 1, b squared is 1, and c squared is our unknown because that's what we're looking for. So I know that 1 squared is 1 times 1, which is 1, plus 1 squared, which is 1 times 1, so another 1, equals c squared. So c squared must then equal 2. To finish that and find BC, I just need to take the square root. So square root of 2 equals c. I can either leave my answer like that, or I can figure out what it is as a decimal, which would be 1.4 approximately. In number 5 is an equiangular triangle. If it's equiangular, that means all 3 of the angles are congruent, which also means all 3 of the sides are congruent. That means that I can set up an equation that says n squared equals 3n plus 18. There's 2 ways to go about doing this problem. You can either set it up as a factoring quadratics trinomial problem. Since it's been a while since you've done that, you can also guess and check here. So I can look to see what could I plug in for n that would give me equal things on both sides. And after trying that for a few seconds, or a few minutes, you might be able to find that n is equal to 6. However, if I wanted to do it as a factoring quadratic trinomial problem, this is how I would do it. So I'd say minus 3n on both sides, minus 18 on both sides. And I would end up with n squared minus 3n minus 18 equals 0, because if I'm going to factor, I need it equal to 0. Think back to your Algebra 1 days when you were factoring quadratic trinomials, and you know that every quadratic trinomial breaks into a binomial times a binomial. I know that the first term has to be n, because n times n gives me n squared, and then I need something that's going to give me negative 18, and also going to add up to negative 3, which ends up being negative 6 and positive 3. So that means I have 2 possible solutions here. N equals positive 6, because we use the opposite sign, or n equals negative 3. Since n can't possibly be negative 3, because distance cannot be negative, the answer has to be 6, n equals 6, which means I plug that back in to find that PQ is equal to 3 times 6, which is 18, plus 18, which is 36. And it's okay if you didn't get that one. We are going to spend a lot more time going over more complicated problems that involve quadratic trinomials. The last rewind problem, number 6, has 2 triangles right here. I know that angle IHJ is a vertical angle to GHK, so if this is 28, this must also be 28. If this is 28, these two have to be equal because it's an isosceles triangle, so all I have to do here is 180 minus 28, subtract that, and I end up with 152, and then I have to divide that by 2. And when I divide 152 by 2, I get 76. So angle K must be equal to 76. We're going to talk today about angle bisectors and perpendicular bisectors, and we're going to start with distance and perpendicular bisectors. So I'm putting a couple theorems up on the board, but I'm going to break them down for you in a second. So just take a look at these theorems. I'm going to read them, and then what you're going to end up doing is using these to prove different sides of triangles are congruent, or different angle parts or pieces of pieces of bisectors are congruent. So perpendicular bisector theorem 5.1.1 says if a point is on the perpendicular bisector of a segment, then it is equidistant from the end points of the segment. So take a look at this figure right here. A perpendicular bisector, remember, A perpendicular bisector is XY is a perpendicular bisector if it goes through a line and cuts it in half. That's what bisect means. And also meets it at a right angle. So we would say XY is a perpendicular bisector here because it's perpendicular to AB, and it also cuts AB into two congruent sides. So AY is congruent to YB, which means XY is a perpendicular bisector. Now, if it is a perpendicular bisector, that means that from this point up here to any point on the segment, it is equidistant, which means I can say that XA is congruent to XB. So if a point is on the perpendicular bisector, so if I take from point A up to any point here on the perpendicular bisector to the same point, it's going to be congruent. I'm going to draw this again to give you a better idea of what I'm talking about. Let's say I say that QB is a perpendicular bisector because it cuts AC in half and it meets it at a right angle. So QB is a perpendicular bisector. That means if I draw a line from A to Q and from C to Q, I know that those two lines must be congruent. So I can say that AQ is congruent to QC because QB is a perpendicular bisector. So that's the theorem 5.1.1. The second part of this is the converse of the perpendicular bisector theorem, which again, converse means just flip it, so you're doing that backwards. You're saying if a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector of a segment. So this would just be going backwards. So I've got my figure here, I've got XY right here, and I've got A, B, the segment right here. And I know that AX is congruent, and I know that XB is congruent because that's what it's telling me right here. If I know that those are congruent, then I know that XY must be a perpendicular bisector. Therefore, XY has to cut this and form a right angle, and it means that AY has to be congruent to YB. So that's just the backwards form. So again, that would look like this. If I have this segment right here, if I have the segment AB and BC, and I know that AB is congruent to BC, then I know BD must be a perpendicular bisector. Because if these two line segments, AB and BC, are congruent, then that means BD has to be a perpendicular bisector, which means that I could say that this angle is a right angle, and that AD is congruent to DC, because that has to be a perpendicular bisector. So using those theorems, how could I find the measure of YW? What would be the measure of YW? We know that it would have to be 7.3. Because looking at this figure, I know WZ is a perpendicular bisector because there's a right angle and there's two parts are congruent. Therefore, this line, XW, must be equal to WY or YW. So YW must equal 7.3. To find the measure of BC, this is using the converse. I know that BA is congruent to AC, therefore I know AD, or line L, must be a perpendicular bisector. So this is perpendicular, makes a right angle. If this is 16, then BD must also be 16. The question says, what is BC? So BC would be what? Good, BC would be 32. BC would be 32. Okay, the angle bisector theorem and the converse of the angle bisector theorem are pretty similar. An angle bisector is a ray that cuts through the middle of an angle. So looking at this figure right here, the angle bisector would be PC because it's cutting through the middle of an angle. And I know it's a bisector because APC is congruent to BPC. So these two angles in here are congruent, which means PC must be a bisector. If that's the case, then it is equidistant, so that means it is the same distance from this point C to get to A and to get to B. These must be equal to each other. So AC and BC must be equal to each other. So we would say then, let's say AC were 6, then BC would also have to be 6. The converse of that theorem says, again, I don't know anything except I know that AC is congruent to BC, and I know that this line PC cuts the angle somewhere, but because AC is congruent to BC, I know for sure that angle APC must be congruent to CPB. So that's just converse of, which means it's just backwards. So here, I'm given that the two line segments are congruent, and that lets me prove that the angles are congruent. Whereas up here in the top one, in the original theorem, I know that the angles are congruent, therefore I can prove that the line segments are congruent. So how would I use this at work? To find the measure of something like LM. Taking a look at this angle right here, I've got this large angle JKL. And I've got a ray shooting through what looks to be the middle of it, KM, and because it's got these lines right here, I know that these two angles are congruent, so JKM and MKL are congruent. Therefore, these two pieces must also be congruent. So if JM is 12.8, LM must be what? LM must equal 12.8. Down here in number 2, given that ABD, I want to find the measure of ABD, given that ABC is equal to 112. So the whole angle down here, ABC, is 112. Now I know that this is 74 and this is 74. So that tells me that BD is a what? BD is an angle bisector. And if BD is an angle bisector, then that means that it cuts these two angles in half. I'm sorry, it cuts the big angle in half. So each of these two angles is a half of 112. So to find out what ABD is, all I would have to do with 112 is what? Divide by 2. So 112 divided by 2 gives me 56. So ABD must be 56 degrees. All right, so at your boards, I want you to do 6, 7, 8, and 9. So head to your boards and do 6, 7, 8, and 9. Okay, now that you've done some of those practice problems, we're going to move on. And what we're going to do next is we're going to try to find the equation of a line that is a perpendicular bisector. So this problem says write an equation in point-slope form. Just as a reminder, point-slope form is y minus y1 equals m x minus x1, where m is the slope and y1 and x1 are the points that I'm using. So any point on the line I plug in for y1 and x1. So I'm looking for an equation in point-slope form for the perpendicular bisector of the segments with endpoints A and B. So the first thing I want to do here is I want to plot endpoints A and B. So A is at -1, 6, so I go over -1 and then I go up 6. And then B is at 3, 4, so I go over 3 and up 4. And here's the segment. And I'm looking for the segment that's a perpendicular bisector. So that means cuts it in half and also meets it and forms a right angle. So how would I do that? How could I take a look at this segment here, and I want a line that's going to cut it at a right angle, and I want it to cut it right through the middle? Well, the first thing I need to do is to find out where the middle is. So how do I find the middle of any 2 points? Hopefully you guys are saying we use the midpoint formula. And as a reminder, the midpoint formula is x1 plus x2 over 2, comma y1 plus y2 over 2. So the first thing we have to do is find the midpoint. So the midpoint of this would be x1 is -1 plus 3 over 2, and y1, 6 plus 4 over 2. Now I'm going to simplify these, and I end up with 2 over 2 and 10 over 2, which further simplifies to the point 1, 5. So my midpoint then is 1, 5. So there's my midpoint. The next thing I need to do is figure out the slope. And I know the slope of anything is just y1 minus y2 over x1 minus x2. So y1 here would be either 6 minus 4 or 4 minus 6. I'm going to do 6 minus 4. So 6 minus 4 over negative 1 minus 3, which ends up giving me 2 over negative 4, which simplifies to 1/2, but a negative 1/2. So if the slope of the red line is negative 1/2, and I need the perpendicular bisector of that, then I need the slope of the line that is perpendicular to my red segment right here. So since the slope of that is negative 1/2, how can I find the slope of a line that's perpendicular to that? Hopefully you guys are remembering that slopes of perpendicular lines are opposite reciprocals of the slopes that we already have. So if the slope is negative 1/2, that means the slope of the perpendicular line would be positive 2 over 1. So positive 2 over 1. So if I want to plot that, I can go up 2 over 1, or I could go down to negative 1. And then this would be my segment that's a perpendicular bisector. But the question says I need an equation in point slope form. This is no problem because I already have a slope right here, and I already have a midpoint right here that it goes through. So I just put that together into my point slope formula. So that would be y minus 5 equals 2 over 1. You could just write 2. I like to leave slope as a fraction, but you could just write 2 over 2 times x minus 1. And that will be the equation of your perpendicular bisector. So there are several steps there, and I'm going to write those down for you on the next slide so that you can try these. So the first thing you want to do is find the midpoint. The next thing you want to do is find the slope. The third thing you want to do is flip the slope to get the opposite reciprocal. And then the fourth thing you want to do is plug it in. So I'm going to do this one so that you guys have another example. So the first thing I'm going to do is find the midpoint. So I do 3 plus 1 over 2 and 6 plus 2 over 2. Which gives me 4 over 2 and 8 over 2, so that ends up being 2, 4 for my midpoint. The next thing I want to do is find the slope. 6 minus 2 over 3 minus 1 gives me 4 over 2, which equals 2 over 1. Flip and negate the slope, so it's going to be negative 1/2 for my new slope, and then plug that in. So my formula ends up being y minus 4 equals negative 1/2 x minus 2. So I give you a coordinate plane, you don't even really need to use it. You can plot both of those and check it just to make sure it visually looks like it's a perpendicular bisector, but again, we can't assume anything in geometry, so as long as you've done this work right here, you don't need a picture to prove it. All right? Go ahead and try these two at your boards. Try these two at your boards, find the point slope form of the perpendicular bisector of these segments with the given endpoints. Okay, now that you've finished with the practice, once you're finished with the practice, go ahead and do the exit ticket. This is kind of a lengthy exit ticket, so I'd like you to just do either 1A or 1B, and 2A or 2B, and then do number 4. So you should only be doing 3 on your exit ticket, and you're going to do those on the slides and then turn them into your sub before you leave. So do those on the 5.1 slides, put your name on it, and turn it into the sub before you leave.